In this video, I'm going to show you the basics of functions in Python. And functions, of course, are one of the key things that give computer programming languages such power, because they are sections of code and logic that can be conveniently reused in many different contexts. Now, the screen you're looking at is, of course, the Spyder IDE. When you finish the last video, it's possible that you had the IPython console over the editor like this, because that's how I was using the console in the previous video. And I wanted to make sure that you know how to get the console back into its usual position. And you do that by just putting the mouse over the bar, left-clicking, and then dragging it down to where you want to drop it. So because I'm trying to define functions in this video, I'm not going to want to just type the commands into the console, but rather I'm going to want to use the editor. So let's begin with a very simple function. I'm going to create a function that just returns the squared value of a variable. To define a function in Python, you use the def keyword, and then you give the function a name. So I'm going to call it myfun. And the function can take one or more arguments. So in our very first function, it's only going to take one argument, x. Now, we get into the characteristics of Python that are kind of unique. I need to finish this line with a colon. Okay, and incidentally, it's very important that this line not be indented at this level. And now I'm going to type the body of the function indented. Okay, so in Python, it's actually the indentation that tells the interpreter, the console, what pieces of code belong together. So I have a function here that has an argument x, and I'm going to now create a variable y that is just the square of x. So it's going to be x raised to the second power. And then I'm going to have a final statement that tells what the function is going to return. And so I'm going to return the value of y. Okay, now, to tell Python that the function is ended, I need to have a blank line, and then I'll take the indentation back out for any code that I write after this. So, for example, I might now print the value, myfun, evaluated at, say, 5. Okay, so 5 squared obviously is 25. What we're going to be looking for here as an answer is 25. So let's go ahead and run this code, which I'll do by selecting it. And then I'm going to go ahead and hit F9, which will run the code in the console. So look over here to the right. So you can see what's happened here is the function has been defined, and then the print myfun of 5 statement has been executed, and the result is 25. Now I'm going to show you some interesting things about how functions work. The first thing is, suppose I had defined a variable before the function that is called x, and let's let x have the value of 10. This x, it has nothing to do with the x inside the function. So the x inside the function is local in scope. If this x right here somehow became the value of the x inside of this function, then the returned value of y ought to be 100. But what you'll see is if I run this block of code, so it's F9 again to run it, you'll see that x is assigned to 10. The function says square whatever argument you give to it. The print my function says a 5, and you get 25. So what this is really showing you is that variables have what's called scope in computing language. There's a range in which they have a meaning and take on values. And this argument x is a local variable to this function. And the fact that x was assigned a value 10 earlier has absolutely nothing to do with how the function is going to work. So I want to show you a little bit more about this idea of scope. And the first thing I'll show you is that if inside this function I change the value of x, so for example, let's put in the line that x is suddenly equal to 27. Then the fact that I've done this assignment of x to be 27 inside the function will not affect its value later on outside the function. So for example, to show you this, I will put in a print of x. Let me grab the block of code and hit F9. What you'll see is that the value of x is still 10. So even though it became a new local x, really a different x than the first x, which has a value of 10, took on a value of 27, it didn't change the value of x outside of the function. Now I want to show you a few more things about scope, but let me first point out what is in here, the variable explorer. And it is listing all of the top level variables, which are called global variables. And for this little program that we've run, there's only one top level global variable, and that's x, and it has a value of 10. Now in just a second I want to show you what happens if I get rid of this statement x equals 10. But if I run this code again in the same console, x is already defined and I won't be able to demonstrate to you what I want to. So to start completely fresh, I'm going to come down to the Python console, the IPython console, and click on this little table thing here, and then restart the kernel. And if I do that, it's exactly like I was just running the console in the beginning. Now I want to show you what happens over here when I get rid of the statement x equals 10. Well, x is a local variable to this function. When I call myFun with an argument of 5, x gets set to 5, it then gets squared to 25, that gets set into y, x gets set to 27, but then the value in y, which is 25, gets returned. Well, I now come down here and print myFun of 5, which should be 25, and then I try to print x. Well, at this point here, x never exists. So I'm expecting to get an error message. And the reason x never exists is it only exists inside this function. So it only has local scope. And since I took away where I had defined it before at the global scope, when I had x equals 10 here, x existed down here. But now that it's gone, it doesn't exist. So let's see if that's really what happens. So I'm going to select it again and go F9. And sure enough, if I come down here in the console window, I get a name error that the name x is not defined. Okay, now I want to show you another thing about local and global variables. I'm going to go ahead and get rid of the print statement for x. Let's suppose we were to define a new global variable, a top-level variable, and it's z, and let's give z the value of 15. Now inside of functions you can use these global variables, and I'll show you that. Okay, but you can't change them. At least you can't change them without a little bit more mechanism than we have at this point. But let me show you what happens when I add in z here. Z has a value of 15. When I call myFun of y, x has a value of 5. X squared is 25. And then when the console, the interpreter, hits this value z, it knows it hasn't been defined locally within the function, so it looks up to the next level to see if it's defined, and if it is, it's going to use that value. So it's going to take the 25 and add 15 and return a value of 40. Let's see if that happens. And sure enough, there is the value of 40 that is returned. Alright, now let's suppose though that I actually did want to change the value of a variable, of a global variable. Let's see if I can do that. Well, let's suppose I want this function to change z to 27. I might try to do this, just instead change x to 27, change x to z, and see if that does it. But my guess is, I better print out z, right? We're not going to see that. So print, and I'll use a label so we don't get confused. This is what we're looking at. So now when I run this, I'm wondering whether I'm going to get the z as a value of 15 or the z as a value of 27. So let me run that code. And what happens is kind of interesting here, because I get this error message that says a local variable z is referenced before assignment. So what's actually happened here is when the interpreter has gotten to this statement z equals 27, it creates it as a local variable. But it recognizes, so z is now local. It recognizes that z is used here, and because z is a local variable now, it has no value, and that triggers the error message. Well, I can connect the z's inside the function with this so-called global z by actually in a very explicit statement. So if I come in here and say global z, now I'm going to not get any kind of error message at all. Okay, what's going to happen is this statement tells the interpreter that when it sees this z equals 27, z is no longer a local variable, but it's a variable that has been defined globally. So let's see if that works. And sure enough now, if I look at the output, z exists, I don't get an error message, and z is in fact this value of 27 that I defined inside the function. So I think I've told you everything I want to tell you about scope at this point. What I want to show you next is how you can have multiple arguments in a function and how you can have default values for those arguments. So I'm going to think of a little function that will take a vector of length 3 numbers, square them all, add them up, and return the value. So I'm just going to highlight everything here and just start from scratch. I'm going to define 3 variables, x, y, and z. So I'm just going to pick the numbers 1, 2, and 3. And so now I'm going to define a function, and I'll just call the function f in this particular case, and it's going to take arguments x, y, and z. Now I need the colon again. That's what is telling Python that we're about to get this block of code that will be delineated by the indentation. So what I want for my return value, which I'll call out, is I want x squared plus y squared plus z squared. And then I'm going to return out. And now when I get down here, I want to print the value of out. Sorry, not print the value of out. Print the value of f of x, y, z. So the little function that I just defined here ought to take 1 squared, which is 1, then 2 squared, which is 4, 4 plus 1 is 5, and then 3 squared, which is 9, 9 plus 5 is 14, ought to return the value of 14. And so let's put a little label here to make everything clear. And I'm going to go ahead and run it. And sure enough, I get an answer of 14 here. Now, let's suppose that I didn't always want to put in all of the arguments. Okay, and let's see what happens when I only put in 2 of them, for example. So let's go down here, and I'll print again f. And this is f of x, y, and z. But now I'm going to leave off the third argument z. Let's see what happens. So I'll go ahead and hit F9. And I get an error here that says f takes exactly 3 arguments and 2 are given. Well, what I want to show you next is how to make arguments optional by giving them a default value. So I can make this argument z optional by putting in here z equals 0. Now if I run this little piece of code, what the interpreter is going to do if I don't have enough arguments is it's going to say, oh, I'm going to see if this one has a default argument, and if it has one, I'm going to use that. So now I'm expecting this to run just fine. So let's go ahead and highlight it and hit F9. And sure enough, I get a value here, f of 5. Well, let's check that. What we had now is f of 1 and 2. So 1 gets squared, that's 1. 2 gets squared, that's 4. Plus 1 is 5. And z gets set to 0. Now if I want to, I can give default values for all of these. In which case, I can skip, in a sense, arguments other than just the last one. Here I didn't use the z, so the last one was left off. But suppose I didn't want to use the x. Well, if I name all of them, I can in fact do that because I can use those names in calling the function. So let's print f here. And in this particular case, what I want is f of, well, I don't want to use x. I will use y. And I can use this y equals y and z equals z. Okay, now in a way it was a bad choice for me to use x, y, and z as the names of the variables out here and then use them again in the function. I'll clarify this. But what's going to happen here is the function will know that the first argument here corresponds to the y argument. And it will use the value that's over here in that argument. So that comes from the 2. And then the same thing for the z here. So what we're really expecting to get is x will be 0, 0 squared is 0, y will be 2, 2 squared is 4, z will be 3, 3 squared is 9, 9 plus 4 is going to be 13. So we're expecting this last print statement to be 13. So let's see what happens. And sure enough, there it is. It's 13. Okay, now just to be very clear about what's going on here, I could switch it up. If I say f, and let's see, I want to use the default value of x, so I won't have anything called x. But the y argument might take on the value of x. And the z argument might take on the value of y. So now let's look at what's going to happen. What this says, as it's read by the interpreter, is the y argument, which is the second one. There it is. The y argument is going to take the value that's in x. So the second argument will be 1. The z argument will take on the value of y, which is 2. So that will be a 2 right here. The x argument is never defined, so it will take on a value of 0. So this ought to be exactly the same as f of 0, 1, 2. Again, there was no x argument defined here because there's no x on the left-hand side of these equal signs. The y argument took on the value of x, which was 1, and the z argument took on the value of y, which was 2. So let's see if these two numbers, when they're printed out, really are exactly the same. And sure enough, if we look at this last statement, it's f is equal to 5, 5. Let's check it. What we should have had was 0 squared is 0, and then the y value was 1, 1 squared is 1, and then the z value was 2, 2 squared is 4, 1 plus 4 is 5. So finally, I can actually say this yet a different way just to make absolutely sure that we're clear about this. This should be the same as f of, well, 0 is the default value of x, so I can skip that. So now I can say that y is equal to 1 and z is equal to 2. And so now when I run this code again, what I should get is the same number for all three of these ways of calling this particular function. So let me hit F9 again. And you'll see that sure enough down here it's 5, 5, and 5. So I've told you, I think, everything I want to tell you about the basics of functions. In my examples, I've always used functions that have just taken a single number as an argument, but actually these arguments can be any kind of data object that Python recognizes. And of course you can learn a lot more about functions by reading in the Python documentation, but I think I've covered the basics that you need to know. It's very important, obviously, to understand what a function is. It's also very important to have some idea of this notion of scope, because the scope of the variables and errors in interpreting that or writing code is quite common. So you're very likely, if you're involved in any kind of data science project, even if you're not coding, be hearing a discussion, obviously, of functions, but then of the scoping of variables.